So the first curve that I want to look at is T6. And the reason I want to look at T6 is because this has a rotation on it that we haven't actually talked about. We've talked about rotations 90 degrees clockwise, but only around the origin, not around the point 1, comma 1. So I just want to show you what that looks like. So just as an overview, remember that this is the word description of the transformation that's happening. This is like the algebraic description of what's happening, so we're going to try to come up with that if we can. This is the pre-image, so the image before, and then the image, which is the drawing afterwards. So we're given the drawing after and the description of what's happening. So I'm going to use my patty paper for this rotation. So I'm just going to trace my image here. And I'm going to trace the X and Y axis a little bit so that I can see exactly where I'm rotating. And the way that we usually rotate, or that I find easiest to rotate around a different point, is I go to that point, so 1, comma 1 would be right here. And I now pretend that my axis is there. And so now what I'm going to do is, like we do with rotations, leave your pencil here, and then I'm going to rotate 90 degrees clockwise. Well, the problem is that this is what happens after the rotation. So if we went over here and we rotated something 90 degrees clockwise, this is what we're going to end up with. So we kind of need to do the opposite of that in order to go backwards. So what I'm going to do is put my center here, and then clockwise would be the direction that a clock goes, so it would be to the right. So I'm going to do the opposite of that. I'm actually going to go to the left. So I'm going to rotate 1 full quarter turn, because that will be 90 degrees, and that will give me this shape. So I see that I'm going to have a point here and here, so let me draw those, and I'll have a point there and there. So I'll lightly draw my shape here so that I can see that, and then I'm just going to go and put it over here on the before. So let's see, right there, 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 and I'll shade it in so that I can see it a little better. Okay, so now let's look at, I want to look at some of the points, the vertices of this shape, to see if I can find a pattern and see if I can come up with a rule for my algebraic expression. So right here I've got 2, 3, here I have 2, comma 1, 1, comma 1, and 1, comma 2. And then over here on my pre-image, I have 1, comma 1, 1, comma 2, negative 1, comma 2, and 0, comma 1. So I need to see the pre-image and image drawings and how they match up to each other. So for example, this top vertex up here used to be, I'll write these in the middle, it used to be negative 1, 2, and now it has become 2, 3. Right below that was 1, 2, and it became 2, 1. This point here used to be 1, 1. I see that point is there. It's still 1, 1. And then my last one is 0, 1. And it became 1, 2. So what I want to try to do is see if I can find a pattern between any of these numbers. So one of the things I noticed almost immediately is that over here I have my y value. So 2, 2, 1, 1. Over here that y value became the x value, 2, 2, 1, 1. And that seems to happen every time. So let's start with x, comma y. And our new shape will give us y. It'll swap to that. And now we just need to figure out what this part will be. So this is the part that's a little bit more complicated. So I'm going to see how that actually relates to these numbers here. And also you can think about the rule that we know for rotating something 90 degrees clockwise just around the origin itself. We know that something about x and y swapping and one becoming negative, so this kind of makes a little bit of sense. So if I think about that this original y value became the new x value, I bet this original x value has something to do with my new y value. So let's kind of look at these numbers. So in this case, they happen to be the same. In this case, it became a 2, and then in this case, it became a 3 from a negative 1. So this would take a little bit of playing around with, and a little bit more rules than we know at this point in geometry. So I'm going to try a couple of things. So one of the things I'm going to try is if I had swapped and put the x here, and this time if I make it negative, so let's say negative 1, if I take the opposite of that, that's positive 1. Opposite of that is negative 1, so let me list out these. So positive 1, negative 1, negative 1, that's just 0. And the reason I'm doing that is because when I rotate 90 degrees just through the origin originally, I do that with the x. I take the opposite sign for that x value. So I'm thinking about those numbers, and then let me compare those numbers to these and see if I can find a pattern between them. So to get from 1 to 3, I add 2. Well, to get from negative 1 to positive 1, I also add 2. Same thing here. And to get from 0 to 2, I add 2. So it looks like what's happening is I'm taking negative x, so the opposite of my x value, and then I am adding a 2. So I'm going to go up here and write my rule in this blank. Y negative x plus 2. And then if you guys don't get that one right away, that's fine. This is a more complicated one. That's why I picked this one to think through. But just notice how the points are changing, and that's how I suggest going about this problem.